Welcome, Algebra 1B students. In this video, we will be talking about how to solve a quadratic equation by completing the square. Before we do that, though, let's have a recap of the two techniques we already have to solve quadratic equations. Let's see, the first one was solve a quadratic equation by factoring. So suppose I had x squared plus 8x plus 15 equal to 0. When I solve a quadratic equation by factoring, the idea here is I can rewrite this as two linear factors, x plus 3 um, times x plus 5. This is sometimes called the Marf method, looking for factors of 15 that add to 8. Sometimes we call this reverse FOIL. But either way, we're going to be able to use the zero product property here and say that if two things multiply that equal 0, namely x plus 3 and x plus 5, then either one of them could be 0. So either x plus 3 equals 0 or x plus 5 could be 0. This is going to result in two answers, x equals negative 3 and x equals negative 5. That is solving an equation by factoring. The lesson we did yesterday was to solve an equation with the square root property. And an easy example would be something like x squared minus 9 is equal to, let's say, 21. When we solve this quadratic equation, we're going to isolate the x squared. We'll do that by adding a 9 to both sides. That gives me 2x squared equals 30. We will undo the multiplication of the 2 by dividing by 2. That gives me x squared equals 15. And then the square root property says that if I have a square, I can undo that square by taking the square root. Now, what we do to one side, we must do to the other. So taking a look on the left-hand side, the square and the square root cancel. That leaves me with x equals two answers. I've got to throw in a plus or minus radical 15. So once again, these are two techniques that we've already learned about. The problem with these is that they only work on special quadratic equations. The factoring only works on factorable quadratic equations, and the square root property only works when you have a single x. The next technique, called completing the square, is nice because it can work on any quadratic equation. So let's look and see what it looks like. Once again, this slide is going to motivate why we need this technique. If I try to factor the given quadratic equation by marfing it, finding factors of negative 10 that add to 6. Let's see, factors of negative 10 are negative 5 and 2, negative 2 and 5, 1 and negative 10. And if we look at all the possible factors of negative 10, there are none. So this is a non-factorable quadratic equation. I cannot use the square root property because I have two x's here. I have an x squared and an x. Looking back at our example, you note that that only applies when you have an x squared term. All right. Now here are the steps we need to do to complete the square. We're going to write the quadratic function in standard form. That means we'll write ax squared plus your bx plus c. We will move c to the other side of the equation. It will be set equal to 0 in standard form. We will divide by the a. We will find a new c using b divided by 2 squared, and then we'll add that new c to both sides. We will then factor, and then we'll square root. Please pause this video as needed, but I'm going to go ahead and move on. and we will do 3 examples. Here's the first example. This is already in standard form, so they're going to ask me to move over the c of 2, and I can do that by subtracting it. Alright, so I'm going to move that 2 over here. Now the idea here is that I'm going to make a new c, one that makes the left hand side a perfect square. And that's why it's called completing the square. So let's see, this new c is going to be found by taking half of the b. The b is equal to 6 here. And I'm going to square that. So let's see. This will give me half of 6 is 3, and then 3 squared is 9. So that is my new c. All right, so I'm going to go ahead and put that into my equation, 9. And what I do to one side, I must do to the other. I've got to pay for that by putting 9 over here. And so we're going to clean things up here. The left-hand side is factorable. And it's set up that way because of my formula. If I take half of b and square it, I always will get a factorable quadratic. We're looking for factors of 9 that add to 6. Let's see, I believe that's 3 and 3, but that's set up for us. And so what we have here is a factorable quadratic. It's going to be x plus 3 to the second. Now on the right hand side, I've just got to clean things up. Negative 2 plus 9 is 7. So what I have now is a case where I can use my prior knowledge. I can now take the square root of both sides, and that's going to undo the squaring, which gives me x plus 3 is equal to positive negative 7, excuse me, radical 7. And then getting x by itself, I'll get x equals positive negative radical 7 minus 3. All right, let's look at another example. Here's one where you've got to make sure that you do this step right here. After we subtract c, we're going to divide everything by a. I did not have to do that on the first example because a is equal to 1, and it's redundant to divide by 1. But in this case, notice here a is equal to 2, b is your 24, and then c is the negative 36. You cannot complete the square if a is not equal to 1. So we're going to make a equal to 1 by dividing every single term by 2, which is a okay step to do. This will give me a quadratic equation with the leading coefficient of 1. So let's go ahead and write these terms out. That's going to be a 12x. That'll be a minus 18. And then I'll get equal to 0 over 2 is 0. All right. Now I'm going to rewrite my quadratic equation, and I'm going to make room for a new c. Let's see. That means I have to move the old c to the right side. That's the 18. So adding 18 to both sides, I'll get it over here. And I'm going to add a number to both sides. This number is found by taking half of b and squaring it. So let's see, we'll take half of 12 and square that number. So half of 12 is 6, and then 6 squared is 36. So that is the new c that I'll be adding on the left-hand side to make a perfect square, a factorable trinomial, but I've got to pay for that by adding it to the right side as well. All right, now the next step is I will factor the left-hand side. What are factors of 36 that add to 12? That's going to be 6. So it's going to be x plus 6 times x plus 6. And then we would write that as x plus 6 to the second. Adding 18 and 36, let's see, that's 52. Now what we'll do is we'll square root both sides. I'll get x plus 6, getting rid of the square, equals positive negative 52 square rooted, so square root of 52. And then what we'll have to do now is just subtract the 6. So I'll get x equals -6 plus or minus square root of 52. All right, so there's the second example, noting that we must divide everything by a to complete the square. Let's do the third example. Here's a situation where we would want to move the 1 over first before we divide by 3, because dividing by 3 would give me a 1/3. So I would probably go ahead and move the c term to the right. So 3x squared plus 12x equals, let's see, it's going to be 1 minus, take away a 1 to get a 15. Now I can see everything's divisible by 3. So let's clean that up. We're going to divide by a. We cannot complete the square if the leading coefficient's not 1. So we can make it 1 by dividing by the 3. This gives me x squared plus 4x. And I'm going to go ahead and make room for the new c right here. That's going to be equal to 15 divided by 3 is the 5. And then I have to add that c to the right side as well. So using that formula, let's see, c is going to be half of 4. We're going to take half of 4 and square it. Let's see, if we take half of 4, that's 2, and squaring the 2 is equal to 4. So that is the number that I have to add to the left to make this a factorable trinomial. But I'm going to pay for that by adding it to the right as well. I'm going to factor the left side. That's going to be x. Let's see, factors of 4 that add to 4. Factors of 4 are 2 and 2, so it's going to be x plus 2 to the second power. And that equals 9. Notice here we have the same process as the other two examples. We will undo the square by taking the square root on both sides. So that gives me x plus 2 equals positive or -3. And now we're just going to isolate the x by subtracting a 2. So x equals -2 plus or -3. Since we do have integer answers here, we can clean things up a little bit more. So x could be either, let's see, we're going to take -2 plus 3, which is 1. Or we could have x equal to, let's see, it's going to be -2 minus 3, which is the -5. So in this case, we have two answers again, and it's no surprise here because all quadratic equations will have two answers. As we go back and look at these examples again, we have two answers here, -6 plus or minus radical 52. One thing we might correct on this one or make it a little bit more cleaner is I can actually simplify this 52 here. The idea is if I can find factors of 52 that are perfect squares, then I can clean it up. Let's see, 52 and 4. 52 divided by 4 is 12, but I want to... all right, 52 is 4 times 13, and so that will allow me to rewrite this as -6 plus or minus square root of 4 is 2 times square root of 13. So even though my first answer wasn't wrong, this is the answer I'd want to look for when I can simplify 52. And so once again, the purpose of this technique is that the completing the square technique works on any quadratic equation. So it's as opposed to these two techniques we did at the beginning where we could factor or we can use the square root property. It's nice to have a technique now that works on any quadratic equation, and it's called completing the square.